Hi guys, and welcome to today's tutorial. Today I'll be giving you a look at how to complete a site localization within the Leica iCON field software. So localization is a term referring to GPS. It can also be called a site calibration or a transformation. It's really all depending on the software that is used. But it refers to a mathematical process used to relate local grids relative to a national grid. In other words, it stitches your GPS's location onto predefined points that you have already established on your local site. So what I'm going to do is just run through a couple of scenarios, jump into the coordinate system tab. So we are connected up to a GPS here, which we can see here. Okay, and we can see ourselves moving around, and we have some control points there on site. Okay. So the first check you would always normally do is if you're provided with coordinates, what you'll do is you'll come in and you'll select stakeout. You select one of your points and you will stake the point out, and you can see, if I say now I'm over the nail, you can see there it's within 8 mil and it's perfect in height. That's obviously an ideal scenario, but I could come and I could get over the point and I could say, okay, I'm within 8 mil in position, but you can see there I'm 80 mil in height, or 60 or 40. Okay, and we want to get it down closer to 0. So we can't actually move the physical nails themselves, control points that we are going to physically on the site. But what we can do is we can look at our GPS readings, which is being projected by our defined coordinate system, which in this case is ITM Republic of Ireland 15. We can do is we can essentially create a personalized coordinate system that stitches onto those points. So what we can do is we can jump into the coordinate system application here. And probably the two most common ones used are either height transfer or either the two up here, so small area or large area. These are essentially the exact same, bar the fact you might just use one over a larger area. So for like a road job or versus like a local housing project, you might just use this one for. So I will start with the height transfer. So when would we use this instance? So if we turn up on the site and we actually have to tie into an original design, the design might be based off a survey that was done 5, 10, 15 years ago. We don't know when it was computed, but what we do know is we need to tie in our readings in with the design points. So we might have a control point, just the one, or we might even just have a manhole cover level, what's existing on site. So we have two options. If we have a control point, we can select the point and we can navigate over that point and we can record an average measurement. When I selected the point, it actually identified what the height was. So these points actually are all in 2D. They have no elevations. But if I came out to a point out here, deselected this, and if I actually just knew, if I was hovering over a point here and I was actually out on site, I was above a manhole, and I knew that that manhole was 10.5. What I could do is I could just type the height and I could select average. And if I select average, we can see there it's going to record average measure point. So if we're using the standard GPS, we'll hold it straight. However, if we're using the tilt, it doesn't really make a difference if it weighs much more. If you have a bipod, that again would be more advantageous. Okay, so once we're happy, you can see there can be no residuals assigned if we're just recording a height transfer because there's nothing to compare it against. There's no known point. We're just defining what it is. So if I select green tick, finish localization, green tick, it's not possible within the simulator, but essentially what you'll do is you actually create a new coordinate system, and that can then be exported and transferred if there's multiple units out on site. Alternatively, if we have multiple control points already existing on site, we'll just jump into the large area. What you can do is you can select your predefined coordinate system. So I know that those coordinates are actually within ITM 15. Okay, so we can select our coordinate system here. Okay, and what you can do then is it comes up and it says select and measure first point. So if we select our control point, what we can do then is we can jump over it. Once we're happy that our GPS is actually positioned on the control point down that side, we can select average. And again, you can alter the averaging settings. So you can have it to average by number of measurements or by time. So I just have a short averaging sequence here just for the purpose of this tutorial. So you can see there, it comes up green. So the first one is always going to come up green because again, there's nothing to compare it or check it against. So I can select my point. Okay, and select average. I can compute this. So now the fact that both of them are green means that the residuals between these actually tie together. So what we knew what the coordinates were for those 2 points and what we said with their GPS, when you compare the two against each other, they actually tie in quite well, both in position and in elevation. So what I can do is I can select my next point. I can shift over and record an average again. And again, you're not limited to the number of control points you use. You'll always kind of want to have good spread around your site, so good coverage. So if I have a rectangular site, I would traditionally want to have one in each corner over the sides and maybe possibly in the center. What you can imagine is almost like a sheet. Okay, if we imagine a bed sheet, and what you can do is you're actually pulling it down onto the points. So what you get is if we pull the sheet down in a location, the sheet dips and is stitched onto that point. But what you do get is the further you go away from that point is the more it actually translates back to what it originally was. So the more points you have pulling it down, the more accurate grid you'll actually get even in between those points, if that makes sense. So we wouldn't want to have control points just running down one side of our site, because in that line it might be good, but as we move off left or right, the accuracy actually degrades relative to that specific site coordination. So I can select my final point here, move over and select average again. Okay, and when we finish with these points, we can see we're all happy that they're all green. You might get one that might have an outlier. So if I actually select to remeasure this point and I select it over here and select average, so you might have one point that's after being damaged or not. Okay, and what we'll see now is that when we record and we purposely add it off, that the errors will actually be increased. So we can see if I actually deselect number 4, they actually all drop down back to 0. But if I include it, we can see it throws in at actually average. So although I was 150 mil out, it actually averaged the error, which actually is inflicting error on the other stations. So what you can do is you can come in, you can deselect and find out where the error is. So I can see there it's clearly relating to this station 4. So what I could do is, again, I could remeasure again. So I'll just cancel. I'll just remeasure it again there. So if I actually shift onto the point and just record another average measurement. But again, now you should be using a bipod and it should be nice and centered over the point. So it should just be, if that's what it is. If I come in now, we can see that it's a nice good. And what we can see there is a scale factor, which is how much that it's actually warping what the ITM15 grid, which we are manipulating to create our own personalized coordinate system. We could leave the heights fixed and not include them. However, I would always recommend including them. We are aware that GPS elevations are the most inaccurate part of the GPS observation. So we would always recommend the use of localizations out on site. And even if you are already getting good results and we're staking out our control points and they're falling in within 20 mil in elevation, you can improve your accuracy and how well they tie in to your local site grid by conducting the localization. So again, if I select green tick, finish localization, you can create your grid and call it this. But again, the functionality is not supported within the simulator, but you can see where we're going. We can see when it import and delete, we can see our coordinate system ITN15 is selected. What we would end up with is another coordinate system actually placed in here. And what you could do then is you'd be able to export out your coordinate system. So we can see this is the only one active in the project, but if we had one of our localizations and you would export it out as an LOK, again, out to your USB, and then in turn, we can transfer it to multiple devices throughout our site. Okay, and just making sure that everyone is working to the same local coordinate system. So that's us guys for the site localization tutorial. If you have any further questions, please feel free to get in touch.